Hello, Algebra 1 students. Today we will be talking about solving polynomial equations in factored form. This is a self-paced lesson. You are welcome to rewind and re-listen to anything you need to, and if you have any questions, just let me know. So we are going to start by graphing something we are used to seeing, which is a parabola. So let's take out our calculators and we're going to graph this equation right here. So I'm in y2, but that's okay. I'll just put the 0 in y1. So take a second to fill this in yourself, please. And then when we graph this, we do get a parabola. Okay, I'll just do a sketch. Okay, so just for some practice, we're going to find two things. We're going to find our vertex. Remember, our vertex in this case is a minimum. And we're going to find our solutions. Our solutions are our zeros or our x-intercepts. All right, so let's find the minimum first. Second trace minimum. And for left bound, we will go somewhere on the left. And when you're somewhere on the left, we'll press enter once. Right bound, go to the right, and we'll press enter once. And guess, we'll go to the middle, and one more enter, and round please, so this will be about 4, -1. That's your vertex. Now for our solutions, we can just use our second trace 5. Over, enter, 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 give 5, 0. All right, take a second to do second trace 5 and find the other one. And you should get a 3, 0. And again, as a reminder, our solutions represent x-intercepts. Okay, our solutions represent the x-intercepts of our parabola. Now, you may have noticed that your solutions were similar to our factored form here. This is what this is called, factored form. Excuse me. So there's got to be a better way to solve this than by graphing, maybe a faster way. And that's where we have our new method today. So we've already learned how to solve a quadratic in our last 2 units. We can use graphing, like we just did, or everybody's favorite, the quadratic formula. Remember that was x is equal to opposite b plus or minus square root, that guy. But what we're going to talk about today is a new way to solve a quadratic. However, this can only be used when we are in factored form. Factored form looks like something that you could FOIL. Okay, so it's the thing with the parentheses up here. This is factored form. Okay, not standard form. This is factored form. So basically, to solve in factored form, we're going to use something called the zero product property. So the zero product property basically says that if you're multiplying some number a by some number b, and you get 0, then either a or b must also be equal to 0. Okay, because anything times 0 gives you 0. So basically, one of these two things has to be equal to 0. It's because anything multiplied by 0 equals 0. All right, so there are 2 rules for ZPP, or zero product property. The first rule is that you must be in factored form. Okay, so it's got to look like FOIL. The second rule is you must have an equals 0. Okay, it's called the zero product property for a reason. It has to be equal 0. If it doesn't, you cannot do the problem. All right, so this looks complicated. It's really not. It's going to be the same thing over and over again. Remember, zero product property says if you have a number times another number and it's equal to 0, then one of these has to be equal to 0. Okay, that's all that this is saying. So all you're going to do, since this number times this number equals 0, is set each part of your factored form equal to 0, and then you're going to solve. So 2x plus 8 has to be equal to 0. X minus 1 has to be equal to 0, and then we'll just solve like normal. Subtract your 8. And divide by 2. X is equal to negative 4. And on the other side, add your 1. X is equal to 1. These numbers are your x-intercepts. If you graphed this equation right here and did your second trace 5, enter, 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 you would get these two numbers as your solutions. And there you go, that's it. To use zero product property, all you do, the only thing you do every single time is set each piece equal to 0. And then you just solve. Okay, now I want you to notice this has 3 parts. This means you're going to have 3 solutions, which means this isn't technically a quadratic. This would be a cubic problem. Cubic meaning has a degree of 3. It would look something like this. Okay, but we're going to solve it just the same as you always would. Minus your 1, divide by 2. You get x equals negative 1/2. Add your 2, divide by 3. X equals 2/3, and add your 2. X equals 2. Again, these 3 represent the x-intercepts of this equation. And notice again, you're just setting each individual part equal to 0. This is called the zero product property. Okay. All right, so let's try some different examples. This next one has an x minus 5 quantity squared. If you want, you can write this out twice, but remember, you are not foiling, you are solving. Here's the thing though, when you write it out twice, both of these are going to have the same answer. So it's really not necessary to write it twice unless you feel like it. Okay, you're both going to get x minus 5 equals 0. So this gives you x equals 5. And then this one, we do have a fraction. So we will minus our 4. And then remember, you're either going to divide by 2/3 with parentheses in your calculator or multiply by your reciprocal. And your other solution should be negative 6. Okay. All right, next one. This one's a little weird because there's an x out front. This still counts as another part of your equation. Just bring it down. X equals 0. And in this case, it's already solved. So there you go. There's your first one. X minus 10 equals 0. 2x plus 4 equals 0. And then go ahead and solve. So add your 10. X equals 10. Minus your 4. Divide by 2. All right, so again, notice this one does have 3 solutions, 1, 2, 3. This would mean that is a cubic equation. It would have that kind of squiggle graph that I mentioned up here. Again, those are all your x-intercepts. All right, we've got 4 more like this, and then we have another graphing problem. So this one is a little different because technically, yes, this 3 is a part of the equation, but if you come down and say 3 equals 0, well, that doesn't make sense. You can't solve for x because there isn't an x. So that part we're not going to use. You can just ignore that 3. Anything with an x is what you really need to solve for. So 4x plus 10 equals 0, x minus 26 equals 0. And then you can just solve. So if you math rack that, you should get x equals negative 5 halves. And then this one, we will just get an x equals 26. All right, so between number 6 and number 7, one of these will have 3 solutions and one of them will only have 2. So take a second to try to identify which will have 3 solutions and which will have 2 solutions. This is the one that should have 3, and this is the one that should have 2, and that's because this first one here has 3 different places where x occurs. So you do need to set all 3 of these equal to 0. And again, you're solving. I'm just kind of flying through this because this is something that we should be pretty good at by now. Add 5, and these would be your 3 solutions. In number 7, you are welcome to just ignore the negative 2 because negative 2 cannot equal 0. Now, I know what you're thinking. For some of these easy ones like this, it's pretty easy to tell what the answer is going to be. Do you need to show work? The answer is I need to see at least this step. And then if you want to jump straight to your answer, go for it. Okay, but you need to show me how you're getting these answers, and so yes, I do need to see this highlighted part. All right, last one, it's a little different. It has an x squared. Set it up the same, set it equal to 0. But now, how do we solve x squared equals 0? We will root both sides. Ordinarily, you would need a plus or minus, but since it's a 0, it's just 0. Add your 2. And minus your 8. And again, this one has 3 solutions. All right, so if any part of this is confusing you, feel free to call me over. I'm happy to help explain it to you. What we're going to move to now, though, is a dome problem. So we have James and Carl. They've decided to construct a dome in their backyard to put over their pool. The equation of the dome can be modeled by this. We're going to sketch a picture of the graph. We're going to label the vertex and the x-intercepts. Then we're going to find the height of the dome and the width of the dome. All right, so we can go ahead and type this into our calculator. I'm going to just put negative 0.5 instead of the negative 1/2. Now, because we're going to find our x-intercepts or our zeros, I'm going to put a 0 in for y2. That is important if you're going to use that second trace 5 feature. All right, so here's what your picture looks like. Now, we are going to find our vertex, so technically you should change your window, but for now I'm just going to leave it like this. Just make sure you connect those up at the top. Let's find our x-intercepts first. Second trace 5, move it on over. It's somewhere, there it is. Enter, enter, enter. And you should get 5, 0. If you find the one on the other side, it should be a negative 5, 0. Now, you don't need to use your calculator to do this because you're in factored form up here. So all that's happening is that we're taking this first one and we're saying x plus 5 has to be equal to 0. And the second one, x minus 5 has to be equal to 0. And when you solve, you get negative 5, which is that guy, and positive 5, which is that guy. So you don't technically need to do your second trace 5, enter, enter, enter. This corresponds to the width of the dome. Okay, so the width of the dome is from here to here. How many units is that? Well, from here to here is 5 units. From here to here is 5 units. So that's a total of 10 units. And these are always going to be in feet. Okay, so 10 feet wide. Now, for your height. This involves the vertex. You've got two options. You can do second trace and then do your max. Left bound, you'll have to go to the left. And I know I can't see the very top, but I can still do this without changing my window. So once you're on the left, 1 enter. Right bound, go to the right. Get yourselves on the right, 1 enter. Guess, go to the middle. And I'm going to kind of guess just somewhere in the middle there. Remember, anything with an E is a 0, so your answer might look a little different, but it's about 0, 12.5. That means your height is 12.5 feet. Okay, that's your y coordinate. Now, there is a faster way. If your parabola is even and symmetrical over the y-axis, and that will occur when your x-intercepts are opposites, 5, negative 5, 10, negative 10, something like that. We can use something different than max. We can do second trace value, option 1, and your x value will always be a 0. So we'll just type in 0 and enter, and it will jump straight to your y-intercept at 12.5. And then you don't have to do max. Okay, and there you go. So what you want to do now is turn the page to your in-class practice. You're going to give these problems a try. When you're ready, you can check your answers on the board. And then when you think you know what you're doing, you can go to your Canvas quiz. You must get a 4 out of 5 to pass the Canvas quiz and move on to the next assignment. Okay, there are 2 assignments. You have until Monday to get them completed. However, ideally, you get them done before you leave class on Friday. Any questions? Let me know. Have a good one.